right, 6B-1, exponential growth functions. So what I want you to do is I want you to turn it to the back. Okay, turn it to the back. Or if you're in your composition book, you can write on the page that you're going to tape it on, either one. And I want you to write 3 types of graphs. 3 types of graphs. Okay, so this is on the back. In Algebra 1, there are 3 types of graphs that we're going to talk about. What type of graph have we already talked about?
Linear.
Linear, good. So on the left side, I want you to write linear. Okay, linear. Now, draw a little fake graph. And then I want you to draw a straight line going through it. Most of Algebra 1, we spend talking about linear, straight line graphs. Okay? Then, in about a month, we're going to talk about a new type of graph, which is going to be quadratics. Oops. This is an A. Quadratics. Q-U-A. Q-U-A. Quadratics, okay? So draw another fake graph. Do y'all know what quadratics look like? Huh? No. It is a U. So quadratics are going to be a U shape. All right? Then there is going to be a third type of graph. And it's called exponential. Exponential. I want you to draw another fake graph. An exponential is going to look like this. You're not actually going to touch the x-axis, but then I want you to draw it like this. Don't touch the x-axis. Okay. So this is kind of how Algebra 1 is broken up, okay, throughout the year. First, you talk about linear. Okay, a lot of Algebra 1 is all linear stuff. Okay, most of it is. But then we're going to talk about exponential graphs. Okay, linear, we did how to write an equation from a table, how to write an equation from 2 points, how to write an equation from word problems, right? How to graph from word problems. All these types of things we've done have been straight lines. Then we move into exponentials. How do you write an exponential equation from a word problem? How do you graph an exponential equation? What are the key features of an exponential? Then we go to quadratics. How do you write an equation from a word problem? Okay, for quadratic, can you tell me the key features of a quadratic? Can you draw a quadratic from a table? Okay, you do the same things for each type of graph. Are you with me? Does that make sense? Okay, so we did linear. Now we're going to do exponential. We're not going to go as in-depth as linear, okay? But we are going to talk about exponential and how to write equations from word problems and things like that. Then, after that, in about a month or so, we'll move to quadratics. And we'll do all that stuff with quadratics too. Okay, so right now is all going to be exponentials, this little unit. Okay? Exponentials. What does that sound like?
Exponent.
Exponent. Okay? So, first we're talking about exponential growth. Exponential growth functions. What's growth mean?
Bigger.
Getting bigger. Good. Okay, so with linear, what's the equation for linear? No, for linear. Good. So for linear, which is what you've talked about, your equation is y equals mx plus b. Okay? Well, right now we're not talking about linear. We're talking about exponential. So we have a new equation for exponential. Just like linear has y equals mx plus b, exponential has this. Y equals a times b. Notice where the x is. It's an exponent. Okay? Exponential, exponent x. Alright? Where the number a, this first number, a, has to be greater than 0. And the number b in the problem has to be greater than 1. for it to be a growth. Okay, they are non-linear. What's linear mean? Straight line. So these are non-straight lines. I'm going to grab my jacket. Okay. Now, there's a new key word. Okay? It's a new key word, and we call this the asymptote. Let me explain what that is in just a second. Get my jacket on. Okay, asymptote is a horizontal line. A horizontal line. Which way does horizontal go? Left to right. Good. Sideways. Like the what? Horizon. Good. So right above horizontal, I want you to draw your horizon. So it's a horizontal line that the graph approaches but never touches. Okay. So what I want you to think about when we talk about the asymptote, okay, I'm going to turn back over to this page. When we talk about the asymptote, I want you to imagine two magnets. Everybody's played with magnets before, right? Yep. Where you flip one on the back side, okay, and you try to make them touch, and what happens? Yeah, they like retract. They try to push each other away, right? When you turn one of the magnets backwards and you're trying to push them together, they push each other away. They will never touch, right? That is the same thing as an asymptote. Okay? So, where's my little ruler? So right here, this blue line is going to be my asymptote. And remember, asymptote goes horizontally, right? So right now, here's my asymptote. It's really going to be the x-axis today. And this line is going to approach it right here. See how it's approaching? But it's never actually going to touch this blue line, my asymptote. Are you with me? Okay. Now, we're going to get to a point where if this is my x and y axis, your line can go like this. Right? Okay, it can cross over. And now my asymptote would be down here, where it approaches but never touches. Okay? It doesn't have to be the x-axis. Today, okay, 6B-1 and 6B-2, it will only be the x-axis. 6B-3, once we get there, this line will shift up or down, and you'll have different asymptotes. Okay, but I don't want you to start believing that it's always the x-axis, because it won't always be the x-axis. Does that make sense? Are you with me? Okay, so your asymptote. Anytime we talk about asymptote, I want you to think of, okay, it has to be a horizontal line. It has to be the horizon. And it's like magnets, where you try to push the magnets together and they will not touch. Okay? And I'll show you why in a second. All right, so what I did here on notes is we are going to compare what you know, what linear is, right? You all should know how to do linear and graph it. So we're going to do one linear, and then we're going to do one exponential, and we'll talk about the differences, okay? So this side over here is linear. Well, what do you notice is different in the equations? Okay, you have a regular x on linear, and what about the exponential x? It's an exponent. What else is different?
The add multiply.
One is being added, one is being multiplied. Okay, so for linear, we're only going to talk about linear now. Y equals mx plus b. Write that on there because it's linear. Now, what did they do with the mx and the b? They flipped it. They put the b first and then the mx. Is that okay?
No.
Yeah, it's the same thing because your m is always with the x. Your b is the other number. Okay? So it says m is slope. What number is m? 3. And what's my y-intercept? 2. Okay, then it wants a table. So now I'm going to show you a new way to do a table. So everybody make sure you have a calculator. If you don't have one, go get one real quick. Okay, new way to do a table. Okay, go to graph. And we're going to plug this in. Now, in order to get to a table, okay, you cannot graph your equation in relation.
Why?
It doesn't work. I don't know why. You can't get to a table if you do relation. Okay? I'm going to show you how to get to a table in just a second from the graph, but you can't do it if you do it in relation. Okay? See how this says y equals on the notes?
Yeah.
Okay? Well, when you open up the calculator every time, it starts as y equals. So because y is by itself on the notes, we don't need to change the calculator. We don't need to go to relation. So it's just, all we're going to type is 2 plus 3x. And then graph it. Okay. Everybody's look like mine?
Yeah.
Are you doing this with me? The back? You graphed it? Okay, to get to a table, we're going to hit Control T. And a table pops up. Okay, got it? Okay, now, notice on your notes, what does x start with?
-1.
-1. So we need to get to -1 on the table. Did you do relation?
No.
Start over. See if it'll work. Okay. Oh, is your calculator blinking green at the top?
No.
Okay. When x is -1, what is the y? -1. When x is 0 in the calculator, what is y? 2. So you should be writing this on your notes for the table. When x is 1, y is 5. When x is 2, y is 8. When x is 3, y is 11. And then we're going to do 4. When x is 4, y is 14. So your table should look like mine. Okay, now we're going to graph. What do you start with when graphing?
-1, -1. X's. The y-intercept.
Yeah, let's graph how we know to graph. Okay, so we're going to start with our b. What's b mean? Y-intercept, which is at 2. Then what's my slope?
Oh, 3/1.
It's just 3, but because it's a slope, we have to put it over 1. Okay, it's rise, up or down, over run to the right. So am I going to go up or down 3? Up because it's positive. Which way do we always run? Right 1. Then I go the opposite until I can't go any further. And then yes, draw your line. Now, linear, it talks about the asymptote. Remember, asymptote is a horizontal line like a magnet. It won't ever touch, okay? If this line is going on forever this way and going up forever this way, does it have an asymptote that it would never touch? No. Linear does not have an asymptote, so I want you to write none. Okay, now we're going to do exponential. Okay, y equals 2 times 3 to the x power. I want you to go ahead and write your new equation. Y equals a times b to the x. All right, my rate, b. Look right here. Notice that b is with the exponent, right? So what number over here is with the exponent? 3. So that's my rate. A is what? The number without the exponent. So that is 2. What does A stand for? Y-intercept. Now, I want you to notice something. For linear and exponential, this is your y-intercept. Okay, they both happen to just be the same numbers. Don't worry about that, as much as your y-intercept is the number without the x. You'll hear that? Your y-intercept for linear and exponential is that number without the x. It could be any number. It doesn't have to just be 2. It's whatever is without the x. Okay, now I want to fill in my table. So we're going to go to a new graph. Remember, don't do relation. It's already y is killing me right now. It's already y equals, and my paper is y equals, so I'm just going to do 2 times 3. And then to get the exponent, we're going to hit this button right here. And it will give you the little exponent box, and then we're going to put x. So everybody should be plugging this in their calculator. Then hit enter. Does that look like the one we drew on the back of the paper?
Yeah.
Yeah. Okay. Okay. Then Control T, and let's fill out our table. We're going to start at -1, just like the table on the paper does. When x is -1, y is 0.66 repeating. When x is 0, y is -2. When x is 1, y is 6. When x is 2, x is 3, y is 54. When x is 4, y is 162. Hey Bryce, will you do me a favor? Will you switch the light switches? Because this one is on, and it's hard to see the calculator in this video. Thank you. There we go. Okay, thanks. All right. This is much better.
It's like a lot.
No, I like it a lot better. All right, now let's compare the tables. Okay, let's compare these tables. Look at the y's on linear. What's it going up by every time? -1 to 2 is a +3, 2 to 5 is a +3, 5 to 8 is +3, 8 to 11 +3, 11 to 14 +3. That's a constant. Look at exponential. Is it jumping the same amount every time? No. What do you notice? It's multiplying by what? 3 every time. Okay? Notice how fast and quickly these y's get really, really big. Does that make sense? Okay? It goes from 0.66 to 162 in 4 jumps. These are steady. Okay? It's steady. It's steadily getting bigger each jump. These are jumping really, 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 really quickly. Okay? So now we're going to graph this. And I'm going to start by using my table as ordered pairs. So at -1 on the x, what is the y? 0.66. So it's just a little over halfway. When x is 0, y is, I don't know why I put -2. When x is 0, y is 2. When x is 1, y is 6. 1, 2, 3, 4, 5, 6. 2 and 18, that would be like somewhere way up here, right? So this graph, if you notice how large the numbers are getting very, 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 very quickly. So it's got to go super up, okay? So now if I draw it, remember, it's got an asymptote, and right now the asymptote is the x-axis. So when you draw your line, don't let your pencil touch the x-axis. Okay, now let me show you. The x-axis, all right? Asymptote, which way does asymptote have to go? Horizontal. So it's really like a Hoy problem. Hoy. And I'm going to write the asymptote as y equals. Well, what number on the y-axis is this a line approaching but never touching? It touches 0.66. What does it not touch? 0. For the y, it's the x-axis. Well, the x-axis for y equals is at 0. So it's y equals 0. So it's never going to touch the 0, which is the y-axis, or the x-axis, sorry. Okay, if you look at your table, if I scroll up, I want you to notice my y's, my y numbers. Is it ever touching 0?
No.
No. It's getting really, really close to 0. Shh. It's getting really, really close to 0, but it's never actually gonna touch it. Y'all see that?
Yeah.
Forever. Never. It's magnets. It's like the magnets turned backwards. They're never, ever gonna touch. Now, okay, because this box, listen, because this box only holds so many numbers, if I go up again, it's a weird way to say that, see the 7 right here? That means that there's 7 zeros before this 418. So like this is 0, 0, 0, 0, 0, 1. It's really 0, 0, 0, 0, 7 times and then 418.
How?
How what?
How does that? Yeah, like how does it turn on?
It's just a scientific notation way to write something. Okay? Because there's not enough room to write it in the box. You guys don't learn about scientific notation? Maybe you do, you just haven't yet. Okay. So, anyways, it gets really, really close to 0, but it never touches because of the asymptote. And right now,
So
y equals
science-
0 is my
science
asymptote.
and math, like,
Oh, yes. Science and math correspond a lot. Okay? All right. Questions?
No.
Okay, let's practice.